Electrolytes. Electrolytes are substances that consist of charged particles called ions in a solution. When electrolytes are dissolved in water or any other polar solvent, they produce positive ions or cations and negative ions or anions. Electrolytes conduct electric current when they are in an aqueous solution or in the molten state. For example, sodium chloride dissolves in water and dissociates into sodium cations and chlorine anions. Therefore, sodium chloride can conduct electric current. Some polar molecular compounds, such as ammonia NH3, are non-electrolytes in a pure state. But ammonia becomes an electrolyte in an aqueous state. When ammonia is dissolved in water, it dissociates into ammonium ions and hydroxide ions. All electrolytes do not conduct electric current with the same potential. Strong electrolytes. When electrodes are immersed in a sodium chloride solution and connected to a bulb, the bulb glows brightly. Almost all the sodium chloride dissociates into sodium and chloride ions, which conduct an electric current. Sodium chloride and most soluble salts, inorganic acids, and bases are strong electrolytes. Weak electrolytes. When the electrodes are immersed in a mercury 2 chloride solution and connected to a bulb, the bulb glows dimly. Mercury 2 chloride partially dissociates into ions and produces few ions. Mercury 2 chloride, ammonia, and organic acids and bases are weak electrolytes. Non-electrolytes. When the electrodes are immersed in a sugar solution, the bulb does not glow. Since glucose is a molecular solution, it does not dissociate into ions. Therefore, does not conduct electricity, so it is a non-electrolyte. Summary. An electrolyte is a compound that conducts an electric current. Strong electrolytes are substances that only exist as ions in a solution. Weak electrolytes partially dissociate into ions.
Electrolysis of water. Electrolysis of water is the process of decomposition of water into oxygen and hydrogen gas with the aid of electric current. Electrolysis of water can be demonstrated through a Hofmann voltmeter. The voltmeter is composed of a set of 3 glass tubes connected to each other. Each outer glass tube is fitted with a platinum plate. The plate connected to the negative terminal is the cathode, and the plate at the positive terminal is the anode. Both the electrodes are connected to a battery. Pour water into the central tube so that the outer tubes are filled to half. When a current is passed through the Hofmann voltmeter, water dissociates into H+ and OH- ions. The H+ ions migrate to the cathode, and the OH- migrates to the anode. Oxygen gas forms at the anode, while hydrogen gas forms at the cathode. The gases collect at the top of the 2 outer tubes, where they can be collected by opening the taps. The overall reaction indicates that the amount of hydrogen gas produced is double the quantity of oxygen produced, which can be seen as the differences in water levels in the outer tubes. Summary. Decomposition of water into hydrogen and oxygen gases with the help of electricity is known as electrolysis of water.
We all know that a water molecule is made up of two parts of hydrogen and one part of oxygen. That is H2O. But can you pull the oxygen atoms away from hydrogen atoms? Maybe not physically, but there is another very simple way. If you want to break apart a water molecule, you will need a glass beaker, water, salt, carbon rods, 3 electric cells with a combined potential difference of 6 volts, a switch, connecting wires, and a piece of cardboard. Now, in the beaker. Click on the beaker filled with water from the list. Next, add salt to the water. Click on salt from the list. Pure water is a bad conductor of electricity. Adding salt to the water increases its conductivity and speeds up the splitting process of water. Now immerse both the carbon rods in the salt solution. These will act as our electrodes. Click on the carbon rods to use them as electrodes. Next, connect the electrodes to the battery and the switch. Click on the cells to make the connections. Now, let's turn the switch on and let the current flow through the circuit for 15 minutes. Click on the switch to turn it on. Now observe the electrodes carefully. Do you see the water bubbling near the electrodes? What's happening? Let's find out. When you switch on the circuit, electrons flow from the negative terminal to the cathode. The hydrogen component in the water molecules accepts these electrons to form hydrogen gas. At the same time, the oxygen component of water gives away its electrons to the anode to form oxygen gas. These electrons go back to the battery, completing the circuit. So to split water into hydrogen and oxygen, all you have to do is pass electric current through it. This process is called electrolysis. To check if the gases formed at the electrodes are hydrogen and oxygen themselves, we can do a small experiment. Take a beaker filled with water. Take 2 heavy carbon rods connected to wires at the base and place them in the beaker with the bases submerged in water. These are the electrodes. Connect the wires to the cells and turn on the switch. Invert water-filled test tubes over each of the electrodes. See how the water level in the test tubes is falling down. This is because the gases formed at the electrodes are pushing the water down to make place for themselves. Notice how the water level of one of the test tubes is lower than the other. Because there are 2 hydrogen atoms in a water molecule, the hydrogen gas collected is double that of oxygen. The moment you bring a lighted matchstick near the test tube that cover the cathode, it dies out. This test proves that the gas collected at the cathode is hydrogen. Be careful because hydrogen gas is explosive and therefore dangerous. When you take a lighted matchstick near the other test tube, it burns brightly. This test proves that the gas collected at the anode is oxygen. Be careful as oxygen gas is also flammable and can be dangerous.
Hey, I've got a new bicycle. This old keychain doesn't go with my brand new cycle. But it's my favorite keychain. I don't want to replace it. Wait a minute. I've got an idea. How about copper plating the keychain?
Can you help Vijay to electroplate his keychain? Electroplating is a simple process where we deposit a layer of any desired metal on another metal using electric current. First of all, you need to prepare the electrolyte. It's the electrolyte that provides metal ions which would be deposited on the object. As we need copper ions, let's prepare a copper sulfate solution. Take distilled water in a container and dissolve copper sulfate powder in it. To increase the conductivity of the solution, add a few drops of dilute sulfuric acid to it. Now, take a copper plate or any other metal with which you would like to plate the keychain and clean it with sandpaper. Also, clean the old keychain. They will be our electrodes. Now, connect the keychain and the copper plate to a battery and a switch. Dip the two electrodes in the copper sulfate solution. Notice that the object which needs to be electroplated is connected to the negative terminal of the battery. In this case, it's the keychain which now acts as the cathode. And the metal to be deposited is the anode. In this case, the anode is the copper plate. Now, switch on the circuit and allow the current to pass through the solution for 15 minutes. The copper sulfate solution undergoes electrolysis. It splits into copper and sulfate ions. The cathode, which is the keychain, attracts the free positive copper ions towards itself. The copper ions accept the electrons from the cathode to form copper atoms. As long as the switch is on, the electrolyte continues losing copper ions. The copper plate attached to the positive terminal of the battery gives away its ions and restores the copper ion level of the electrolyte. Thus, copper gets transferred from one electrode to another, and the process continues till the current flows through the circuit. Don't you find the keychain shining with a bright metallic copper color? What do you think should be done to coat an object with silver instead of copper? The electrolyte should be replaced with a silver compound such as silver sulfate and the copper plate with a bar of silver.
My keychain is now as good as new.
Electroplating. Electroplating is a process that uses an electrical current to coat a conductive metal with a thin layer of another metal. The process itself is done through the use of an electrolytic cell. Such cells have the ability to decompose chemical compounds by converting electrical energy into chemical energy during a process known as electrolysis. A basic electroplating setup consists of an electrolyte and two electrodes, a cathode and an anode. To see how this process works, we'll walk through the electroplating of an iron spoon. The spoon will function as our cathode, and a nickel rod will function as our anode. The electrolyte will usually be a solution composed of water and dissolved ions or molten salts. In this case, the salt utilized will be nickel chloride salt. Our cathode, the spoon, will be connected to the negative side of a battery by a wire. Our nickel rod, the anode, will be connected to the positive side of the power source. As an electric current is passed, the nickel chloride will begin dissociating into negative chloride ions and positive nickel cations. The negatively charged chloride ions will migrate towards the positively charged nickel rod on the anode. The positively charged nickel ions in the electrolyte will migrate towards the cathode, where they will be reduced to nickel metal and form a coating on the spoon. Electroplating can be used to change the physical, chemical, and even mechanical properties of an object. Low-cost decorative finishing can be done using this process. It is also widely used with keepsakes that are gold or silver-plated. Summary: electroplating is a process that utilizes an electrical current to coat a conductive metal with a thin layer of another metal. An electrolytic cell is used as a key component in the electroplating process. Positive ions in the electrolyte migrate to the negative electrode known as the cathode. Negative ions migrate to the positive electrode known as the anode.